So continuing from the previous video, so it is I can simplify it. So it will be 2y over 1 plus x cubed. So I can see that it's the same. So this means that now the equation in the new form after multiplying by the integrating factor is in the exact form. So we can go ahead and find its solution. So the solution will be f will be equal to integrate the either of the m or n function. So the new m is this, and we can integrate it with respect to x. So we will get this, and then for the constant of integration we will process the further steps. So we take the partial f over partial y. So I can take f, we can represent it by fy, and then derivative of f with respect to y. So it will be minus y over 1 plus x square. Okay, so this I can compare with the new n. What was new n? New n was this, and how it compares with the new n. So it is y is common, and then on the top it is 1 plus x. So this needs to be simplify. Okay, this new n. Okay, so I actually I should have simplified it before. Simplify new n. Okay, so it is minus y over 1 plus x square. So since now this partial derivative of f with respect to y is same as this, so therefore the constant of integration is 0. Is a this will mean that the constant y over here, which will be added over here, is not a constant in y. It will be just a constant. So therefore we can write the answer like this. Okay, so the answer is this, and that is equal to c. I don't know whether we can further simplify it or not. So let's see if we can simplify it or not. So simplify this left hand side and then enter it. Oh, sorry, it should be a double. So it does not simplify more. So this is the answer. So as a preference, one can represent it into the partial fraction. So it should be 8 over 2. So it will be 4 over 1 plus x square, and it will be 4x over 2. It will be 2x over 1 plus x square. So in terms of the partial fractions, this answer can be also represented. Okay, now look at the next example. Okay, so we can solve this equation with the help of a linear differential equation approach. So we can first divide both sides of the equation by x square minus 1 to make it in a standard form. So let's execute this first. Okay, so it will be, it's like this. Okay, so we can take this equation and then divide both sides of this equation by x square minus 1 divided by x square minus 1. and also divided by x square minus 1. And then on the left hand side, we will need to simplify. Also, we need to tell that to Mathematica that we need a simplification of that. Okay, so I can close the simplify over here. So we have now got the equation in the simplified form, in the standard form. Even I think we need a simplification on the right hand side as well. Simplify. So now the right hand side has also been simplified. So for a linear differential equation, we need an integrating factor. So mu in this case will be equal to exponent of this 2 over minus 1 plus x square. So we can copy and paste over here, but actually it's quite easy. But just to introduce you a new function, then I can just tell you that we call this function as the p, and this function is basically a coefficient of this y. Okay, so we can use a coefficient command, and then input this function over here. That means this whole value, and then we want to find that that we need the coefficient of y. Okay, so close it and then enter it, and then we get the coefficient of this. So this is the value of p. So now we can find the integrating factor mu, which is the exponent of integrate p with respect to x, and then close. Yeah, so this is the integrating factor in this case. However, this integrating factor is not in a simplified form. So here I think sometimes Mathematica does not provide immediate simplifications. Probably this simplification command will also not work over here. So if it does not work, then you can do it manually. Oh no, it works. Okay. Yes, so I need to provide the simplification command. Okay, so now we got the integrating factor. So as the next step, now what you can do is, you know that for the linear equation, the integrating factor mu times the y is equal to the integrate mu times the value, the function on this right hand side. Okay, so we can just copy and paste it over here. Control V, and then we are going to integrate it with respect to x. Close it, and we need to write it in the equation format. So double sign, and yeah, okay, so we have this. So I can execute it. So it is like this. So here it has input the value of minus 1 over x plus x, the value of mu, and then after integration, it is because it was also multiplied by mu integration, we got minus x. So now in this next step, we need to manually enter the constant of integration. And now we can further simplify it in terms of y. So for y, we need to multiply it by 1 plus x divided by 1 minus x, right? Both sides of the equation. And multiply control v. And then just in case we can tell if it to simplify it for us. Okay, let's try without simplification. So yeah, so we get this. So I think in this case we don't need any simplification. The answer is already simplified. Okay, so now we have this question. So this question we will solve by the substitution method. So let me write it over here, this equation, and we get it like this. Okay, so for the substitution we will apply, you can either apply the substitution u is equal to y over x, or y is equal to u is equal to y over x, or u is equal to x over y. So any of these substitution can be applied. In this case, maybe we can use this substitution u is equal to y over x. So u, so maybe you can type, I can type it over here, u equal y over x. Okay, so here you can see this arrow sign is a combination of two keystrokes. So first keystroke is your minus sign on the keyboard, and the second keystroke is your caret character, right caret character, which is the key next to the question mark, okay, or the forward slash. So this symbol is used for assigning the values. Okay, so I'm using it over here. I have not assigned it, but will tell the application of that to you later. So if u is equal to y over x, then y will be then u times x. Okay, and you can also represent dy over dx is equal to something like this, or you can also represent dy as, so dy will be equal to u dx, okay, u times dx plus du times x from the product rule. Okay? So we can use these types of substitutions into this equation. Okay, so for the application of this, then I will use this equation, and I will copy and paste it over here. And now I want to apply these substitutions. So I need to just input replace two values, y with u times x, and dy with u dx plus dxu, dux, u dx plus dux. Okay, so for this, at the end of this equation, I will put a forward slash and then full stop. This will be the symbol, this will tell that I am going to replace some values. This is the end of the clip, so I will continue it in the next video clip.